Assalamu alaikum. I'm Basil and I'm back. And for today's topic, I'm gonna talk about AND OR trees. So we're gonna dive into what AND OR trees are and especially the depth first search with AND OR trees. We all know that AND OR trees or any kind of trees in general are mainly used for problem solving and decision making in AI, and it helps us make a decision. For example, let's just say there's an example out there for, is the person ABC a boy or a girl? So it's going to be on the top, and then we're going to traverse down. If he's a boy, does he have long hairs or short hairs and other things? And then in the end, the AI is going to give us its decisions from its knowledge, either it was a boy or it was a girl. So it's a basic example right now. Let's dive into what AND OR tree is. Basically, you can say it's got a tree structure like any other tree structure in computer programming or in computer sense, but it's a graphical structure to solve mostly multiple conditions and decisions at the same time. So right now, the example that I gave you guys was, is he a boy or girl? But there are going to be more or multiple conditions and decisions at the same time, which it's going to look at. It's going to traverse through every decision, trying to get the proper answer that validates it. By using it, this is one of the basic uses of AI problem solving, you can say, or basic level ones. Let me tell you what is the main thing in AND OR trees. The main thing is there are AND nodes and there are OR nodes, same as AND gate and OR gate. For AND nodes, all the conditions must be true for it to be accepted, and for an OR gate or for an OR node, only one condition out of any other condition needs to be true for it to be accepted. So all child nodes must be satisfying the parent node in the condition of AND nodes, and for all OR nodes, only one child needs to satisfy it and the work would be done. So, and we're gonna place conditions in those scenarios, in those places where it's gonna be giving us the correct answers. Another day-to-day example we can add to it is, if you want to play a game or we're playing a game. Let's imagine, for example, let's just say we're playing chess, and we're going to use AND OR tree to give us the best strategy. For example, if I move my pawn to the location, this one, this tile or this tile, would it succeed with all my other, you can say, moves? And at the end, because human mind, maximum it can, normal mind people, they can think for 5 to 10 moves ahead of them. But mostly games, when common people are playing it, it doesn't end in 10 moves. It goes way more than 10 moves, mainly 50 moves or whatever. So the computer, it calculates all those 50 moves from my starting move, and it gives me out that either I will or not. So it's a small example. We'll dive into it. Now we're gonna talk about a little bit of one of the best, you can say, strategies out there, or best algorithms we can put on this problem or AND OR tree, is depth first search. For you guys, let me tell you what's the basic or the easiest way for a depth first search. The way I'm looking at a tree, it will traverse to the smallest root at the leftmost, and when it reaches the last root or the last child, not the root, the last child from the left side of the tree, while we are looking at it, from there it will traverse up to its parent and then all the child of its parents. Again, if the condition satisfies, then that would go to its parent's child, and then all that its parent, and then all the roots of its parent's child. So the thing is, it traverses like that from left to right, then up, then up, then up, and if there's more children's, it goes down there, comes back up, comes to the root, and then to the right side, and completely and traverses like that. So how it basically works is, this is its basic working. And when, let's just say, it's on the bottom left child and its parent's child is an AND node, so its parent node, so what's going to do is, it's going to traverse up to its parent and to all the other children's around, and if all of them satisfy, then that node would be accepted, and then it will traverse upwards. If not, it would be rejected. It's going to move on to the other one. And if it's the condition of all nodes, only one child, that's going to lead to the solution, to the goal. It's going to satisfy our condition, what we want. For example, of the chess game, we want to win. For another scenario, let's just say, we all know there's a very famous scenario out there. It's called maze, in which there are paths right and left, and we don't know which path to take, and we have to traverse through it, because some parts can be dead ends and we have to come back. So in that case as well, it does it. For example, if one node is gonna lead me out of the maze at the exit, and it's an OR node, we're gonna take it. That's it. Another question can be like, why are we using depth first for AND OR trees, whereas we can use other as well? Yes, we can, but for depth first, it basically has the ability of backtracking as soon as it fails, and it saves us a lot of time. And other than that, it's a very efficient in making decisions. Plus, its most uses in the AI world are games, like simple games, not very complex games. We can apply it to the complex ones, but from the simplest to the complex ones, decisions are made on subnode levels, and those can be done by AND OR tree with depth first search. So guys, that's it for AND OR tree with depth first search. I hope you guys understood. It's a simple concept, and I also told you guys how depth first search really applies. So the combination of these two, the AND OR tree and the depth first search, it's pretty powerful tool in an AI, and helping us making pretty efficient decisions. And it also pretty efficient decisions while not by looking at all the possibilities very deeply and smartly. So there are a lot of other things. I want you guys to look in your everyday life, small problems or games that could be applied to depth first search and OR tree. Thank you guys, and I'll see you guys in the next one.